Okay, welcome back everyone. Today we're going to do a continuation of our lesson on the unit circle. But today we're going to talk about when we have angle measurements that are greater than 360 or 2 pi, or we have negative angle measurements. Because as you can clearly see, those are not represented on the unit circle, so we're going to have to do an extra step before we can use the unit circle to find the values of our trigonometry functions. So let's say, for example, I'm given the angle of 510 degrees. Well, I'm going to start here at 0 degrees. If I go around the circle once, this is 360 degrees. But then I have to keep going to get to 510, excuse me. So how much farther are we going to go? So if you have an angle that is larger than 360, we're going to subtract 360 degrees from that angle. Repeat until your angle is between 0 degrees and 360 degrees. So if we take 510 degrees and subtract 360 degrees, then we're going to get 150 degrees, which is between 0 and 360 degrees. So this is the angle we want to work with, which means we rotated around the circle once, came back here, and stopped in quadrant 2 at 150 degrees. Okay, so let's look at another example. Let's say you were given 1125 degrees. So let's subtract 360 and see what happens. That results in 765 degrees. But this is still larger than 360. So let's subtract 360 again. 405. Still bigger than 360. So you just repeat the process until you get a number between 0 and 360. So subtracting 360 again, my answer is 45, which is in the first quadrant. So this angle is between 0 and 360, and that's equivalent to 1125 degrees. Okay, what about negative angle measurements? If I have negative 75 degrees, well, normally when we go around the circle, we're going counterclockwise from quadrant 1 to quadrant 2, 3, 4, etc. Negative angle measurements go clockwise from 0. Okay. So we need to find the positive angle that will make this an entire circle. In order to do that, if it's a negative angle, instead of subtracting 360, we're going to add 360 until the angle is between 0 and 360 degrees. So positive, we subtract, negative, we add. Negative 75 degrees plus 360 degrees is 285 degrees. That's in quadrant 4, and so That's my answer. That's between 0 and 360. Let's try another. Negative 775. So we just keep adding 360 until we get the answer we're looking for. Negative 775 plus 360 is still negative 415 degrees. Add 360 again. Still have a negative 55. So one more time. We have 305 degrees. That's a positive angle in quadrant 4. So we're done. So we talked about converting when it's in degrees. Let's talk about radians. So remember, to go all the way around a circle, instead of 360 degrees, all the way around a circle is 2 pi. So we're going to complete the same process, but just replace it with 2 pi instead of 360. So for larger angles, we need to subtract 2 pi until the answer is between 0 and 2 pi radians. Now, it's easier. So, for example, 15 pi over 4 radians. So I don't want to subtract 2 pi. We're going to end up with pi in the answer. So let's just deal with the numbers and add pi into our answer. You leave the pi alone. Otherwise, you're going to get crazy decimals, and that's not helpful. So 15 over 4 minus 2 over 1. This is where you can either do it in your calculator if you know how to work with fractions in your calculator, or, as we practiced earlier, make them have a common denominator, and then you can add or subtract the fractions. So this is a 4, and this is a 1. If I want this to also become a 4, you multiply the second fraction by 4 over 4. That would give me 15 over 4 minus 8 over 4. 15 minus 8 is 7. The denominator stays the same. Now this is where we add pi to the answer. So my final answer is 7 pi over 4. I can see that that's here on the unit circle. So that means it's between 0 and 2 pi radians. So this will be my final answer. Let's try another. Got 26 pi over 7. So once again, we're going to leave the pi alone until later. 26 over 7 minus 2 over 1. Multiply the second fraction by this denominator over itself. 26 over 7 minus 14 over 7 is 12 over 7, and add the pi again. You can know if it's a correct answer between 0 and 2 pi if the numerator is less than 2 times the denominator. So 7 times 2 is 14. 12 is less than 14, so it's all good. We could do the same thing here. 4 times 2 equals 8. 7 is less than 8, so it's between 0 and 2 pi radians. And we'll use the same process for negative angles. But instead of subtracting 2 pi, we're going to add 2 pi. So what if I'm given negative pi over 6? I need to add 2 pi. So let's ignore the pi for now. There's an invisible 1 here. So you get negative 1 over 6 plus 2 over 1. In order to get our common denominator, multiply this fraction by 6 over 6. Negative 1 over 6 plus 12 over 6. So negative 1 plus 12 is the same thing as 12 minus 1. So we have 11 over 6, and put your pi back in your answer to do our check. 6 times 2 equals 12. 11 is less than 12, so our answer is in the correct range. Okay, negative 7 pi over 12. Let's add our 2 pi. Deal with our fractions first. So this fraction is multiplied by 12 over 12. Negative 7 over 12 plus 24 over 12. Now, since it's addition, you can switch the order if it makes it easier for you. So negative 7 plus 24 or 24 minus 7 will give you the same answer. 24 minus 7 is 17. Add your pi back into your answer. 12 times 2 is 24, and 17 is less than 24, so the answer is in the correct range. Now let's talk about how this can be applied when using trigonometry on the unit circle. So let's say we're given the angle of 600 degrees. You want to find the angle between 0 and 360 that it corresponds to 600 degrees, the quadrant, and then sine, cosine, and tangent. So the first thing we do, if it's greater than 360, is we subtract 360 until we get an angle that's between 0 and 360. So that's 240 degrees. Is that an angle here on the unit circle? Yep, it's right here. So which quadrant is this? We start here, 1, 2, 3. It's the quadrant where both coordinates are negative. So remember, the sine is your y value, the cosine is your x value, and tangent is sine over cosine, or y over x. So let's look at our angle here. The sine is the y value of the coordinate pair, or negative radical 3 over 2. The cosine is the x value of this coordinate pair, or negative 1/2. The tangent is sine over cosine, or y over x. So negative root 3 over 2 divided by negative 1/2. So remember, there's two ways that we can approach this. You can either keep change, flip. It would be good if I actually flipped it. Negative 2 over 1. The 2's will simplify, and you have negative root 3 times negative 1. A negative times a negative becomes positive, so my tangent is root 3. The other way you can do it, if they have the same denominator and you're dividing fractions, you can cancel them out. You get negative root 3 over negative 1. The two negatives cancel, and we get radical 3. So as you can see, either one of these methods work to get the same answer. But this time dealing with radians. So if we're given 11 pi over 4, in order to convert that to an angle measurement that's on the unit circle, we have to subtract 2 pi until we get an answer that's in the correct range. So 11 over 4 minus 2 over 1, multiply the second fraction by 4 over 4. Now we have a common denominator. 11 over 4 minus 8 over 4 equals 3 over 4, and add a pi back in. So 3 pi over 4 is in quadrant 2, it's right here. The sine, remember, is our y-coordinate, or root 2 over 2. Cosine is our x-coordinate, which is negative root 2 over 2. The tangent is sine over cosine, or negative root 2 over 2. Positive root 2 over 2 divided by negative root 2 over 2. Now, anything over itself simplifies to 1. But because there's a negative here, my tangent is actually negative 1. For our final example, we're going to repeat the process with a negative angle. Let's try negative 330 degrees. Remember, when it's a negative angle, we add 360. So negative 330 plus 360, which is the same thing as 360 minus 330, gives me an angle of 30 degrees, which is here in quadrant 1. Sine of 30 is our x. Sine is the y-coordinate, 1/2. Cosine is the x-coordinate, root 3 over 2. Tangent is sine over cosine, giving me 1 over radical